Hey folks, how are you doing? Well, I see you're really enjoying these little receivers that I'm building. I got just about 2,000 views on this one that I posted there the other night, and there was one individual that gave me a pretty good idea what kind of receiver this is, and this they call it a TRF, Tune Radio Frequency Receiver. So that's pretty cool to know exactly what this type of circuit is, and that I got built here because I really had no idea. I just put it on paper and decided to just build the thing. And then we had another individual that said this is a weak receiver. Well, yeah, it's no stereo system or anything like that. It is what it is. There's no major amplification going on here. It's just something, a bunch of parts put together and made a receiver out of it. It's a junk box special. So it is what it is. It's homebrew. And then I had another individual asking about the transformer here. It runs on a 9-volt battery. A 9-volt battery. 9 to 12 volts, and they asked what's the purpose of the transformer, output transformer. Well, the output transformer is being used as an audio matching transformer for a headphone, for a set of headphones. So it's basically got 1,000 ohms on the input, and it gives me about 8 ohms on the output, 48 ohms on 4 to 8 ohms on the output, which goes to the headphones jack. So basically, when you're using the AC transformer, normally it's 120 volts to 12 volt, 12 volt being your output. Well, when you're using for an audio matching transformer, you use it in reverse. You take your circuit side, this side, and you run it into the 12 volt side of the transformer, and then the 120 volt, or the high side of the transformer, would then go to your headphones. So you're basically using the transformer in reverse. And I picked this idea up off of another YouTuber a couple of years ago, and about using line transformers as audio matching transformers. And well, there you go. That's why I'm using a 120 volt to 12 volt transformer. I'm using it for audio matching, impedance matching for the headphones. The bottom of the radio, there's nothing special about it. Carl gave me the idea of using some inductors on the DC input of the transistors. So that's these three here, 1, 2, and 3. But the transistors are just wired up, same as what the circuit is. But that's it. It is what it is. I think it's a cool little circuit myself. I just built it for the hell of building it. I mean, why not? I got parts, so why not build it? So, seeing everybody enjoy seeing these homebrew radios, well, I just discovered I had another piece of wood right here. That I think what I should do here now is I'm going to draw out another circuit, completely out of my brain, out of my mind, put it on paper, and see if we can build it again. And this time, we're going to build it onto this piece of wood, big piece, building on top of this one, and then we're going to build this from scratch, basically from paper to a sort of working receiver, maybe. But we'll see how that goes. But that's the purpose of this video. So if you want to see this piece of board turn into a radio by first putting it on paper, well, stay tuned. We're going to build ourselves a receiver, and you can stay tuned if you like. We're going to go, I guess, kind of step by step sort of thing, and build one, maybe. If it works, it works. If it blows up, blows up. What am I out? Nothing. Anyway, let's see how it goes. Okay. plain piece of paper. And we've got a plain piece of wood with absolutely nothing on it. So we're going to build a radio based off a schematic right off the top of my head. So of course, well, got to have an antenna. It's your schematic for your antenna. Your antenna got to go into a loading coil. Which goes to ground. There's your coil, there's your ground. Of course, top of your coil, you're going to have a tuning capacitor goes across your coil. So we'll put our tuning capacitor. There's our tuning capacitor right here. Now, my last circuit, we tapped the coil. Do we want to tap the coil this time, or do we just want to use the coil as it is? Basically, we'll wind a bunch of coils on a form and ground it. Okay, let's try it that way, see what happens. So we won't bother with the taps. Taps are, I think, would be better because you can tune the coil a bit better. Or should we put a tunable coil by putting a slug, a ferrite rod inside of it, and be able to vary the impedance or the inductance of the coil by moving the ferrite rod inside the coil? What do you think? We could do that, or we could just use an air wound coil. But in any event, so basically what we want to do then, we're going to dump the signal from the antenna into the transistor. Now the last circuit I put a ceramic capacitor, 0.1 or something, between it and the base. So I mean, in order for us to use our transistor here, you can't supply voltage to the transistor because it would be shorted to the coil. So again, we still need our little capacitor. That's our DC blocking capacitor. So now we can use the circuit without shorting out our transistor. So this is our circuit for our transistor. In this case, we're going to use a 2N2222. Since I have lots of them, why not use it? So, coil, tuning capacitor, capacitor, transistor. Now, we want to supply 9 volts, so we're going to run that across a resistor to make current limiting. We used 4.7 ohms before, or 4.7K, so it worked before, so why not use it again? It works. And then across between the base and the collector, normally there's got to be a resistor across that in order for the transistor to work. Last time we used 820 ohm. We can always change this, but so 820 or 820K is what I used on this the last time. Let's have this capacitor, put that like a 0.1 since it worked last time. The resistor, this one here, I used 820K before, and that seemed to work okay. But can we lower this? Can we put like a 50K or a 4.5K or a 10K resistor across the base and the collector? What do you think? What do you think we can put across there? Should we just leave it as is? Go 820. Let's put a let's go 100K. Just see what would happen. We can always change it. If it blows up a transistor, we'll change it, put a bigger one in there. Now, the emitter, on the last circuit, the emitter went to a tap on the coil. I mean, I suppose if we really wanted to do this, we could put a switch. We could have multiple taps on the coil, and have it switched to the emitter of the transistor. What do you think? Instead of having just one point, how about we put multiple taps? I think that would actually be pretty cool. So let's put back to our coil. We'll put a bunch of taps on the coil. We'll put 4 taps on it. So then we're going to put, let's see, 1, 2, 3, 4. This circuit here is your switch 1, and of course these 4 points correspond to the 4 points on the coil. So we'll go 1, 2, 3, 4. So then we'll go 1, 2, 3, 4. Correspond. These points here correspond to the taps on the coil. Okay. So then we have our output, and that output obviously got 9 volts on it. We'll put 9 volt. We'll put 9 to 12 volt DC. That's the input. So if we read in multiple articles and books and magazines and blah blah blah, each stage has to be isolated from the next stage following it. So in order to block the voltage from one stage dumping into another stage, well, we have to put a capacitor. So that's another capacitor that isolates this stage from the next stage. We'll put a 0.1. See, that seems to work. So right now we have our output. So right now we could, in theory, if we really wanted to, we could put a pair of headphones right on this circuit. So we could put up, across, just like that, and headphones if this went to ground. That's if we want to use headphones, because right here, right now, as is, this is an audio output. This is audio out. The transistor acts as a, I might be getting it wrong, but the transistor is acting as a detector and oscillator. So, because it's oscillating, making this circuit work. So, we have to isolate everything. Now, back here, if there's RF here, or I should say DC voltage to the antenna, obviously you want to put a capacitor here on the antenna input, but we're not going to bother with that. So, you can plug your headphones into this right here as is, high impedance, crystal headphones, and you would probably hear audio. Right now, you hear audio from this circuit as it sits right now. The capacitor could go to 365, could go with a 500, or we could go with 100, 50, whatever you got. I have one tuner capacitor here that was given me by my buddy Bill. Apparently this is a tuning capacitor, a variable capacitor that is fairly sought after from what I've been reading online. I've done a test with the capacitance meter, and it's good for 500 picofarad as is. And the thing about this one, I think why everybody likes it, because it opens up so nicely. Right? So we could use this capacitor for this side right here. We could use this one. Or maybe we can use another small one. I have this small one. we can use this one again. Let me put that one there. We have our switch. It's just an ordinary old switch, nothing fancy with it. That could be our switch right here. If it's a 4 position, 6 position, whatever that switch is, that's the taps we put on our coil over here. And your headphones obviously can be crystal headphones. I find, believe it or not, the Kenwood, I got a nice set of Kenwood headphones here. Nice set. And they're the Kenwood HS5. 8 ohm. They might be 8 ohm headphones, but I find these are pretty good, even for circuits like these. But if we were going to use crystal headphones, I got 2 sets of headphones, crystal headphones. Just while I'll get to them. Got 2 sets. One of them decided to. Oh, I see them. So we have this nice set of crystal headphones. Someone has, again, Bill handed these over to me yesterday. These ones are, someone actually marked them, 3.7K, 37 ohm crystal headphones. And the other set I got, which I use a great deal, I also have these ones. I'm not sure what the impedance are on these. These are trim commercial, these ones here. And they're made in Libertyville, Illinois, USA. These ones here. Trim commercial. These are old as the dickens, I'm sure. I've had these a long time. But this one here, given me by Bill. So these headphones could be plugged into where this is here, and we'd get the sound out of these headphones if we wanted to do that. So again, trimmer, our switch, got our headphones. Now if you want to use headphones like those Kenwood headphones in order to get nice sound out of them, again, you have your transformer. You'll be able to match the high impedance of this circuit to work with those headphones. And that's where a regular 120 volt to 12 volt transformer comes in handy, because I never knew that would work. I really didn't. I had no idea it would work. But let's do a little test here. We're going to get the ohm meter out, and we're going to check the impedance of this. Let's see what the input impedance and the output impedance of this transformer is. So normally the white wires is the 120 volt side, would plug into this side, and your output voltage would be on your blue. So let's break out the old ohm meter here. Put her in continuity, 2K. So let's put her, one probe there, one probe here, and we have on the primary side we have 23 ohms on that side, and then on this side, the secondary side, black is your center ground. So between the two blues we have 5 ohms. We'll go to the black. We have 4.8 there, and 5.5 ohms. You got 5 ohms there. And we have...
What? Ham or hot dogs? What's that? Oh, bombing. Okay.
Maureen video bombing again.
Hold on, folks.
Okay, now that Maureen stopped video bombing us here. So our transformer, let's do this again. White. On the primary inside is about 22.5 ohms on the white. And on the output, between the two blues, we got 5 ohms. Between the blue and the black, which is center, you get about 4.5 ohms. It's not really a really high impedance transformer. So let's see if we can find something else a little bit more suitable than this one. Maybe. Okay, so another transformer here. I have an old tube radio, another audio transformer, I think. But in any event, let's test this one. There's our meter. So we have, say, 800 ohms. 800 ohms on one side. And we have 3 ohms, 3 to 4 ohms on the secondary side. So we can use this one as an audio transformer. So we'll use this one in the circuit. We'll use this one. So how that would work is obviously if we have our 9 volt 12 volt on our collector and we didn't have this capacitor here, we decided to just put our transformer in here like that, right? Say this capacitor was out of it altogether, we'll just go down to here, right? We put our transformer here like that. That's our core. And our headphones. And it'll be ground. Okay? So that's our transformer. T1. So, what do you think would happen? You're supplying 9 to 12 volts to the collector of Q1, which is the whole brains of this whole operation. If we put this transformer to ground through this, what do you think would happen to the voltage? Pretty sure the voltage would be shorted out through the coil to ground, which would effectively kill the circuit. That's why we need the capacitor in there as a DC blocking capacitor. So let's try this again, very quick. Antenna, coil, and of course our resistor, 100K, 4.7K, 9 to 12, 0.1, .1 again. Alright, so our circuit is back. Old circuit, new circuit. Alright, so by putting our capacitor in here for blocking the voltage, for blocking the supply voltage from going across the transformer. So right now, if we really wanted to, I'll just put a dotted line here. Just to represent if we want to put this transformer here. The 100 ohm, 4 ohm. So right now, this transformer, this dotted line means it's not connected, but can be connected. So this transformer would sit right there, which would then would hook up to your, plug in your headphones to that, which match the circuit to your headphones, and that's how that would work. Okay, so we got our audio output transformer for our headphones. So what we're going to do here right now, we could build an audio amplifier circuit here to boost the signal. But what we're going to do right now, we're going to build this part of the circuit right from the antenna right to this transformer to the headphones, and see if this part of the circuit works. So first thing we're going to need is a form for this transformer, or a coil, and I have a couple. I'm going to rewind them, but I have one here already, this one, and I have another one. Another one here. Got a coil wound over and over the other coil, another one here that I could use. But in any event, let's build this side and see what happens. See if we get this side of the circuit to work. On our emitter, we'll go to the coil. So I'm just curious, only curious, if we put a resistor also from the emitter to ground, what would happen? I have no idea. Probably kill off the whole signal in here, the whole signal input to the transistor more than likely, but we'll see. But for right now, we'll just forget about that, and we'll just we'll put in make up the coil, we'll install the capacitor, tuning cap, the isolation cap, put in the transistor, a couple of resistors, matching transformer, and see what happens here. Okay guys, this is what I come up with so far. I got the audio transformer mounted right here. I have the tuning capacitor here. I have the 6-position switch right here. I got a control, either volume control, could be regenerative control, could be receive gain, could be anything. So I had a spot there, so I just installed it. And I got a headphone jack right here. So all the controls are mounted. For the transformer, just put the pins down through the wood and then bent them over. That way the transformer can stay in one spot and don't move. And these two controls plus volume control, it's just a piece of aluminum head kicking around from an old radio, and I just screwed that down into the wood with a couple screws. And the volume control, or the variable capacitor, is just 2 screws that one here, these 2 here, pulls it to the board. So there's our 4, or 3, whatever, other controls. 3 controls, 1 volume control, 1 headphone jack. Gee. Now, so the next thing we got to deal with here, I do believe, is we need to come up with a. We had to come up with a coil. I had to come up with a coil. Trying to get my arm in the way here. So right now, we have our variable capacitor mounted right here. We have our audio transformer mounted here. We have our jack that the headphone jacks plug into. So we got these mounted. And I got another volume control, RF gain, whatever, potentiometer that I can use with this, maybe off the emitter, who knows. So right now we need to come up with an idea for the coil. How many turns total do we want on this coil? I'm going to try to make this for shortwave if at all possible. In the meantime, whatever band it ends up on, it ends up on. If it's on the AM band, it's on the AM band. If it's on shortwave, perfect. But I'm going to aim for shortwave band. So shortwave, well, obviously the signals are very, 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 very weak. You know, in the great scheme of things, for all the amplification and everything else, they're fairly weak because they are coming from thousands of kilometers away. So you want a coil that is sensitive enough to be able to pick up these small signals, tiny little signals. So you don't want like a huge wire for this, I don't think. I think you'd want a rather small, tiny wire to pick up the tiniest signal. So I took the wire off of this coil that was here. And I just wanted it on this piece of cardboard, just for the sake of putting it on something. And the wire is pretty small. It's not the biggest, by no means. I'm sure everybody gets something smaller, but that's pretty small. I've also got, what I used on the other receiver, is I used the wire, the copper wire, off an old transformer that I pulled apart. So yes, if you're looking for an old copper wire, transformers are a great source for this wire. Great source. And this wire here is what I use for the other receiver. So it's a little bit, not by much, but it is a little bit, this wire here is a little bit bigger than this. So I think I'm going to go with the smaller wire instead of that big stuff. At least that's my plan. So how many turns we need, well, that's another story. How many turns we want on our coil? Well, I'm sure that's all a calculation depending on the band you want. So I don't know. I'm going to do a bit of research on the amount of turns I'm going to need for a coil for a specific shortwave band. So what do we want to aim for here? Do we want to aim for, I don't know, we want to aim for 20 meters? Do we want to aim for 40 meters? Do we want to aim for, I don't know, 15 meters? Maybe even 10 meters. It all depends on the wire and on the coil. Of course, all this together really depends on what it's going to receive. But I'd like to get a good chance of this working. So I'm going to aim for, say, let's go for 40 meters, 7 megahertz, because that's usually a nice ripe number for radios usually to fall on. Most of what I build, for the most part, it all ends up on that segment of the band, around 40. So anywhere between 5 and 8 megahertz is where a lot of my receivers ends up. So let's try 40. If I can get 20 out of it, we'll go with that. But let's aim for 40. So I'm going to do a little tiny bit of research right quick and see how many turns of a coil do we need in order to get 40 meters. Now, in saying that, I got lots of taps on this coil. We got 6 taps that we can put on this, and of course the tap is going to be grounded. We're not grounded, but it's gonna basically, we're gonna be picking off certain segments of the coil, certain sections of the coil, 6 different sections. So we'll see how this is going to work out. Hopefully this will work out. But anyway, let's see what I need for a coil. Okay guys, so I've done a little tiny bit of research on coils. So basically this is our turns. We got shortwave 1, 2, 3, and 4. 5 and 6, not sure what's going on with them yet because it's too high in frequency. I'm not sure how many turns I'm going to need or if I'm going to get anything on them. But anyway, so shortwave 1, 1.6 to 3.4, I'm going to need 38 turns on the coil, and between a 4 and a 7 turn tickler. So I'm going to put a tickler coil on this thing. Shortwave 2, which is 3.5 to 6.5 megahertz, I'll need 18 to 20 turns. Shortwave 3 is 5.5 to 12 megahertz. I need 10 to 12 turns on the coil. Shortwave 4, which is 9.3 to 20 megahertz, I'll need 5 to 7 turns on the coil. So back to the circuit. So I've changed it up. So now we've got a tickler coil right here, which sits above the tuning coil, which is here, and the rest of the circuit is staying the same. Now I could, in theory, because I'm not sure about the other 5, about position 5 and 6, I could use one position to possibly add these coils, to the main coil, possibly, maybe, I don't know. I might just leave the tickler as is, or maybe I can use it to switch in a capacitor between the two coils. Just an option, idea. But anyway, so again, antenna, tickler coil, these 2 points here are grounds. That's our main tuning coil. That's our switch, which can be a 6 position, 1, 2, 3, 4, 5, 6. Got our, and there goes the camera. And got our tuning capacitor, which is 365 picofarad. I might change that. That could be any value. Might need lower capacitance for this to work right. And then we have a 0.1 capacitor put here. 2N2222 transistor. 100K resistor between the base and the collector. A 4.7K resistor between the voltage and collector. And then we have 0.1 isolation capacitor between it and the transformer or the next circuit. So basically right now we're going to build this part of the whole radio circuit, receiver, whatever it's going to turn into. We're going to give it a try. So let's build, shall we? Okay, let's move the camera above, straight above. So I'm going to start with the tickler coil first. It says we need 7 turns. So I guess we'll start at the top and we'll put our main coil on the bottom. And I'm going to use this copper wire just because I got lots of it. So I'm going to take off some of this wire. So you must drill a bunch of holes in your pipe. PVC, not PVC, but drain pipe, whatever. The black stuff, you buy. The black pipe. So basically you want this one to be kind of long, because this one's going back to your antenna. So that's your first part of it. Just like that. Now we're going to wind 7 turns without losing it, hopefully. I'm going to take this and poke it inside so it don't want to disappear on me. I'm just going to try and wind 7 turns. This is almost too big. I think this is way too big. I think this form is way, way, way too big. So that's what? 5 turns now? Around one more time. And then this piece goes to ground. Of course, you want this wire to be kind of long again. Now here's the fun part. Trying to get this piece of wire back through that other hole. Just like that. There we go. It's our tickler. Gonna do tickle tickle. It's gonna tickle our main coil, basically, is what this is gonna do. So we need to wind the main coil as close to this coil as possible. Well, not not perfectly, but you get the idea. So what we're going to do, I'm going to put a bit of masking tape, just regular old masking tape, on my coils, just to keep my coils in one spot, because coils love to move. They do not like to stay in one spot. You get packing tape, put over it. Well, hopefully, with any luck, keep everything together. With any luck. There. Just to keep that coil together. This is our ground. That's our antenna. And that's our ground wire. Now, here comes the fun part. Now we gotta wind 35 turns. More wire. I might even wind more than that. Might wind, I don't know. I almost make up 6 taps, so whatever that's going to take now, that's what we're going to do. The question is, should I allow the ground wire just to come straight down like that? Is that going to interfere with the main coil? Because I'm going to take the main coil and go over top of it. Is this going to matter? I don't think so. I don't think that should matter. Because on other coils I see and find in radios and whatever, they got their main coil, they got their ground wires or whatever running vertically next to the other coil. So I can't see how this would be an issue. So we'll go with that. Alright. That's our ground. Ground's always on the bottom. Now we're going to start our other coil. Now, it's got to be close to this one. So, I'm going to have to start at these holes that are no good to me. So I'm going to have to drill a closer hole to these without actually smacking them, hitting them. So I'll drill a hole in here. Bring her back a little bit. Alright. So my next coil is going to start here. So it's going to be next, as close as possible to the tickler coil. I think this here is going to be a bit of a nuisance. I think this wire here. I don't know if I can force it up or not. Possibly. There we go. Now it's up closer. Put another piece of tape over that. Alright. Tickler. Alright. Now, I'm going to wind our other coil. 35 turns, or as many as required to make this to take up 6 taps, because that's what I want to do. So again, in through one hole, out through the other. And again, you want this one kind of long, just because you're going to be building. This one's going to be going out to the. This one's going to be going out to the base. All right. I'm just going to take these guys and stuff them down there for now. Out of the way. Yeah. Now I've got to keep turning these the same direction. Try not to overlap them. If you overlap them, you're kind of going to mess yourself up a bit. 2 turns. What I'm going to do is I'm going to take the wire. It's going to be first tap. I'm just going to take the wire here. I'm just going to twist it together like that. Put a little loop in it. That'll be my first tap. First tap, and continue turning. Put a tap what? Every 5 turns? 10 turns? What do you think? That's 4. Let's say every 5. So that's 5. Come around one more time. There we go. Make another tap. Same with the other one. Don't worry what your tap looks like. We'll deal with that now in a minute. We'll deal with the tap now when we get the coil wound. Sure, there's easier ways to wind a coil, but hey. This is what it is. Unwind that bit of banging there, boys. That take the wire off the old transformer wind thing. What do we got here? That's 1, 2, 3, 4, 5. Go around one more time. Okay. Make another turn or tap. Same with the rest of them. There's probably better ways of making taps, but I'm doing it like this. So we're going every 5 turns and making a tap on this coil. Till they got all 6 put in, because my switch got 6 contacts, so we're going to put 6 taps on the coil. Is this going to work? I have no idea. One, 2, 4, 5. That's 5 more turn. 1 more turn around. Yeah, make another tap. Like I said, your taps don't need to be perfect, folks. These I found they don't seem to make much difference how they're made. As long as they're made. So let's make 5 more turns here now. And whatever you do, don't let go of the wire. You let go of your form, that's going to be like the proverbial spring. And all your wire is going to go flying. Then you get the fun part of everyone in your coil again. Yay! That's something I want to be doing. Wind it once is quite enough. Well, this is the fun part of building your own radio. Is winding your own coil. We got 1, 2, 3, 4. 1, 2, 3, 4. Okay, we got 5 turns. So 1 more. Winding your own coils. Now, motor tap. That's 1, 2, 3, 1, 2, 3, 4. There's 5 taps we got in there now. Use one more tap. One more tap, we'll tap out. Oh, oh, here we go, here we go. Coil's wanting to move. Like I say, I'm hoping this is going to end up on the shortwave bands, but Lord only knows where it's going to end up. We got 1, 2, 3, 4, geez, we got 5 turns already. Wicked. Alright. Round again. We'll make another tap. That'll be our number 6. We'll wind some more. I guess we'll wind another, I don't know, another 5, just to be safe. I know on a lot of coils, they're tapping 3 from ground, 3 from the bottom. I'll go with 5. Just because. I'm not sure. Well, I suppose the switch should in theory change bands, I would think. It's the same thing as adding coils, adding turns or removing turns. So I'll see why it alright, correct the yeah, here's the hard part. There we go. Tape not want to cooperate. Now try and do this with 2 hands. Wow. Holy crap. Wow. Alright. I'm going to keep some pressure on this because I need to get some tape on this coil. And of course, let me tape decides to disappearance. Gotta love that. Tape disappears. Anyway, I'll back 1 second. Okay, well, hopefully that wasn't too painful for you to listen to watch. So, anywho, that's our antenna, top reticular coil. The bottom reticular coil is down here for ground. Then we have the top of our main coil right here. and that leads all down here to your ground. And then we have our taps. We got 1, 2, 3, 4, 5, 6. So we have 6 taps on the coil. So there's our coil form made, and coil or whatever, all made. Now we have to remove the varnish from our taps so we can solder directly to them. Now, I find burning it off don't seem to work that well, but we'll give it a whirl. Trusty torch. We'll give it a whirl. I mean, the flame burned back, so I suppose it should work. Try a bit of solder, I suppose. See if the solder sticks to it. Or flows on it. I've had mixed results with solder with using the torch. I don't think it works that well. Well, it's making a liar of me on that one. Try this one. Working on that one. Working on that one. Working on that one. Working on that one. This one here. The first one. I don't know. There you go. Now it's working. Perfect. There we go. Make these loops. Right, small. Loops don't need to be big. Keep twisting them like that. They don't need to be big. Alright. So that's our coils and our taps made. Yeah. Mount this coil form now to the box there. Breadboard, whatever you want to call it. And continue from there. Alright, stand by. Okay, I got my coil mounted on the board. And I got the grounding done right to the capacitor here, tuning cap. I'm going to leave these ends on there for now. But that's the ground from the coil to the body of the capacitor, according to the schematic. So now we've got these two to deal with now. One goes to the antenna, and one is going to the base of the 2N222 through a 0.1 picofarad capacitorial. So, top one, which is this one, goes to the antenna. So I'm going to run that one straight down the side, drill a hole in the board to run the wire down. Could go that way maybe, I don't know. More direct route, I suppose. Or we can just go down this way, straight down the body of the coil, to the board, and over. I think I'm going to lose length if I go that direction. So I can go that way. There's a more direct route. Well, I'll drill a hole, I suppose, and hook it up. Okay, coil's in. Antenna cable's run down. It's connected to the. It's gone through the board, back up, and then soldered over here. This is the antenna connection. There's a clip on. Grounds are hooked up. I have the wire for to go to the base to the switch right here. Switch is going down, which ends up right here. So now what I have to do is wire up the switch right now. 6 position switch. This one here. This needs to correspond to the taps on the coil over here. So that's our next adventure. So we'll do that there now. Okay guys, I have my coil switch wired up. So basically I'm going to start at the bottom is number 6 and top I mean position 1. So this switch all the way this way counterclockwise is 6. So 6, 5, 4, 3, 2, 1. So you start at the bottom right there. So from the bottom to the top. Kind of makes sense. So that's my connections to my coil, all 6 of them. So on the bottom I solder leads from the switch, or from the coil going to the switch, these ones. That one there is our ground. We got this one here, this wire here, which goes to the capacitor, tuning cap. This one here. Now we're going to make a connection between the switch and the emitter of the transistor. So we got to sink a transistor in here now. So we're going to go with a 2N2222, just because I got lots of them. And the transistor, I'm not using any circuit boards for this at all. All I'm using is the board itself, is what's going to hold the transistor. Actually, it's going to hold all the controls, all the components. All the components are going to be mounted topside and down through the board. Basically, is what's going to happen. So I'm going to spread out the leads, kind of like that. Now I want to make 3 holes to match those pins. Of course, I want the emitter to be first. I want the emitter to be closest to the switch, so I'll put it over there closer. So we'll go 1, 2, 3. And then we'll take the transistor, put that down through the board. Actually, this way. Just like that. And then we're going to spread out the leads so the transistor cannot fall out. So one that way, one that way, and one that way. Just like that. So the transistor can't fall out the hole. Okay. And there's our 2, right here. So I have to get a little wire, go between the common of the switch and the emitter of that transistor. The wire don't need to be all that long. So I'm just going to tin it. I'm going to solder. Oh, this is difficult now. Kind of got myself locked out, so I got to remove this wire. Move that wire temporarily, so we can solder this wire to the common on the switch, which is in there. Melting everything else. And take this wire, solder it back to the switch again. Alright, and take this wire, poke it down through the hole where all the wires are coming out of. Should be, hopefully there's no room there, but one more try. Maybe. Maybe there is. Just barely. Yeah. Very barely. I don't know if I can get through that hole or not. There we go. So the emitter, the transistor, is this side. So we need to solder this wire to the emitter of that transistor. This is the emitter. Just let it. There we go. Emitter's on. Okay. So now we got to go from the body of the tuning capacitor, not the body, but the other pin here. Just jumps across, but this one here, and then that got to go through a 0.1 picofarad capacitor to the base of the transistor. We're just going to mark these. Emitter, collector. So, I'm going to drill another hole for that capacitor. Base is in the center. So, oh wait, we got the pin going backwards. Back. Okay, pin's going toward the back, so we'll put the capacitor here. And then we'll find a 0.1 picofarad and put there. Okay guys, so made a little change on the two capacitors. And this one, change this one to a 0.1 UF and change this one to a 0.1 UF. These increase the signal and the audio a little bit more than the other ones did. And they're also Mylar. Two of those are Mylar. So got the tickler coil on top. It's 5 turns, and it's sitting above L2, and it's basically tapped every five turns going down the length of the coil. So to give you an idea how many turns are on the coil. So you got 5, 10, 15, 5, 10, 15, 20, you got 25, 30, 35 turns roughly, tapped every 5 turns. You got 2 and 2, 2, 2, 2. I'm using the audio transformer right here, matching transformer. So this section here will go on to another section once we get into part 2. We'll put an audio amplifier into it. But right now we'll drive it into the audio transformer. So that is the circuit as it sits right now. And yeah, this is the circuit. I got everything wired up. The coil is wired up to the switch. I'm running on a 9-volt battery. And the coil is oscillating. I just put the headphones up to the speaker here, so you can, or the microphone, so you can hear it. Now, if you take a ferrite rod, you can bring in AM broadcast. So I guess we'll put this down as part 1. So that's part 1, boys, of the receiver. In the next one, we'll add on. We'll add an audio amplifier, maybe another tune circuit after this one. Who knows? But we'll explore that in part 2. But as of right now, this is part 1, and this is the circuit as built. So, anyways, and it's been the coil built on a piece of drain pipe, black PVC or whatever it is, carbon fiber, whatever. drain pipe. So anyway, I may change up the coil yet, but we'll see how that goes. We can always change this section here if we want to. It's no big deal. But for right now, we'll just keep adding on to this and see how far we can push this circuit. Anyway, folks, hope you enjoyed the little video, and we'll chat on the next, on part 2. And I'm glad you're really enjoying the builds, these circuits and stuff I'm building. Right now, I put the other video up on the last receiver. On this one, and I got over 3,000 views on it in like a day and a half, maybe one day. 3,000 views. It's amazing. Very amazing. Anyway, folks, I guess we'll see you on the next installment. Anyway, folks, thanks for watching, and we'll chat on the next one. All the best.